Okay, now we're going to talk about transformations of graphs, which you guys all did through Algebra 2, but we're going to go back over them. So this is the transformation equation up here, which will vary depending on what function that we're talking about. So the D is your vertical shift. So as I go through and look at these, this is what determines my vertical shift. This, and it's add or subtract, so if I'm adding, I'm going up. If I'm subtracting, I'm going down. My horizontal shift is my left and right. And remember, this one is the one that is opposite. We go opposite the sign. So if I'm adding, I go left. If I'm subtracting, I go right. So adding is left, subtracting is right. And the other transformation we're going to talk about is reflecting over x and reflecting over y. We will use the designation of r of x and ry. Reflect over x, reflect over y is what that means. And so here, this is where we do negative f of x, and this is where it's f of negative x. And what this means is when I reflect over x, I change the y, and when I reflect over y, I change the x to its opposite. All three of these, vertical shifts, horizontal shifts, and reflections, are all rigid transformations because the basic shape does not change. So all this does is move it up, move it down, and flip it. And then the vertical stretches and horizontal stretches and compressions is what we're going to look at next. A vertical stretch, this is the A value. So we're talking about this A value. And what that is telling us is when it's on the outside of the grouping symbol, those are where the vertical is located. And when I'm a stretch, that A value is going to be bigger than 1. A 2, a 1.5, a 5, a 3. Okay, and then my shrink, or the other word is compression, which is what I tend to use more. Compression, the A value is between 0 and 1. That means less than 1, but greater than 0. Like 1/2, 3/4, 2/3. Those would be compression or shrink values. The idea with vertical is we're comparing it to the x-axis. So when I stretch it, I'm stretching it away from the x-axis. When I shrink it or compress it, I'm pressing it towards the x-axis. So we're going to use vertical stretch and vertical compression just as the abbreviation as we go. Okay, now on to the horizontal. This is the B value, and it's inside the grouping symbol. So the difference or the comparison between the vertical and horizontal is just think about them opposite. A stretch for a horizontal is where the B value is between that 0 and 1. And a shrink or compression would be where the B value is greater than 1. Just remember they're going to be opposites. This is what we compare to the y-axis. Okay? And we're going to use horizontal stretch, horizontal compression when we're talking about the transformation, unless you want to write the whole thing out. Okay, vertical and horizontal stretch shrink will change the shape of the graph, which means these are classified as non-rigid transformations. So rigid means it won't change the shape. Non-rigid means that it will. Okay, some reminders. Horizontal shift. You must remember if your function has a B value, which is what's inside the grouping, you must factor it out. So for example, if I have a function that's negative, let's do 2x minus 6 squared plus 5. This has a b value of 2. You need to rewrite it as 2x minus 3 squared plus 5. Because what changes is instead of going right 6, I go to the right 3. So you need to pull that out before you do all your other transformations. So keep that in mind. And always remember the first transformation you do is going to be reflections. Okay, now we're just going to practice some parent functions and transformations. I'm going to take a look. This has a 2 in the grouping symbol, so this makes this a quadratic. And then I have a negative on the outside and a minus 3 on the inside. So the negative on the outside is reflect over the x-axis, and the negative on the inside, remember, is opposite, so I'm going to the right 3. Okay, the next one has these long bars, and hopefully you know that that's absolute value. And then this has a 3, which is a b value, so I need to factor that out. So 3x minus 2. So now that's factored out. Remember, we must factor the b. So that 3 on the outside of the parentheses, but it's inside the grouping symbol. So that makes that a horizontal. And since it's greater than 1, it's opposite, so that's a horizontal compression. And then the minus 2 is telling me to go to the right 2. Now this next one, this symbol is a square root. And I also have a b value I need to factor out. A negative is like a negative 1, so that's x minus 4. So there that is in transformation world, and that is a square root. The 3 on the outside is a vertical stretch. The negative on the inside is reflect over y. The minus 4 is to the right 4, and then the minus 2 is down 2. Then this last one, this next one is showing me that it is, because that's to the third power, it makes that a cubic. And there's no b to factor out, so the negative on the outside is reflect over x. The plus 4 on the inside is left 4. And the plus 5 on the outside is up 5. Now the last one. This has a fraction bar and x is in the denominator. That's going to make that a rational function. And the plus 4 is going to move me to the left 4. That's like the grouping symbol. And the minus 3 is down 3. And that's just hopefully a review of transformations for you. Okay, now we're just looking at a piecewise function. Going to go back over and do some things with it here in a minute, but we're going to go back and here's a review. My domain is how far left, how far right. So all the way over here is how far left. I'm connected here, so no gap, no gap, no gap, no gap. So it goes from here all the way to here. And so that's going to give me at -9 all the way to 7. And at -9, it's going to be a hard bracket because that's a point. And over at 7, it's going to be a parentheses because that's an open circle. Now my range is from bottom to top. And so when I do my range, I'm down here at the bottom. and then there's a gap to here. So this is the gap, and then that's the very top. So I'm going to have two pieces of my range. So the bottom is at -6, and it goes up to -1. And at -6 is a hard bracket because that's a point on the graph. And up there at -1 is a parentheses. And then to go with it, I'm going to start off again at 1 and go up to 4. 1 is a closed bracket because that's a closed circle up to a parenthesis. So there's two pieces of my range. Now we'll go to when f is -2. So at -2 is right here. I come down, and the y value at -2 is -5. And then f at 2 is right here, and at 2, that's the closed circle, so that one is at 3. And now, get rid of those, and now I'm going to do f of x equals 1. Remember, that means y equals 1. So at 1, I have this line coming through, and I have two x values. So I'm going to have x equals -1 and x equals 4. And then the last one says f of x at 0. This is 0. There's nothing that touches, so this is an empty set because there are no values at 0. Okay, so I took and wrote down all the coordinates from the part 1 graph down below. This one tells me to let g of x equal f of -x. So what that tells me I'm going to do is change all my x's to their opposites. So this is going to be +9 to 6 and +6 and +5, 4, 3, 2, 1, 1. And then -2, -2, -4, -4, -7. So the x's change their values. Now I'm going to graph them. So I'm going to go +9 to 2, and then +9 to 6, and that is that one segment. Now at 6, at -1, is an open circle. And then 5, +5 at -5. And then 4 is -6. 3 is -6. 2 is -5. And 1 at -1 is an open circle. And this is that quadratic looking thing. So there's that. And now at 1, I'm going to 1, and that's a closed circle. At -2, I'm going to 3. And that's going to be the curve. They don't have to be exact, so I'm just making it as it is. And then at -2, I'm at 4, and that's an open circle. And then at -4, I'm at 1, and I'm connecting those. And then at -4, I'm at -3, and that's an open circle. And at -7, I'm at -1, and that's an open circle. And there I have graphed changing the x, which means we reflect it over, and hopefully you know why. So this is a reflect over y when I change the x. Now I'm just going to answer questions by looking at this new graph. When this graph is at -4, I am at +1 because the other one is an open circle. And when I'm at positive 2, I'm at negative 5. And when my graph is at positive 1, I have two values, and that's going to be x equals negative 4 and x equals positive 1. And then when g is 0, it's still an empty set. Okay, now we're going to talk about regressions and transformations. You can do these three different ways: one with your calculator, one by using the transformation equation and finding the a value, or you can look at the graph and determine the a value by pattern. So everybody's kind of at a different place on what we can do. So on this video, I'm going to show you how to use the calculator in the first one and how to use the transformation equation in the second, and talk about patterns on both. Okay, so this first one is a quadratic because of the shape of the graph. I know that. I know that the vertex is at 5, 2. I know that the a value is for sure negative because it's opening down. And then all parents use the pattern from the vertex of 1, 1, which would mean I go right 1, up 1, which is there, but I go right 1, down 3, so that makes my a value negative 3. So I know that I can write this equation. I have everything that I need. The negative 3 is on the outside. X minus the x coordinate of the vertex squared plus 2. So that is all I need to do if I understand my patterns. Now on this one, I'm going to write out the steps of using your calculator. You're going to go to Menu and go to Stats. And you're then going to input x and y values into their appropriate place. Then you're going to hit the button that says Calc, which is the F2 button up at the top. Then you're going to hit the Reg, which is for regression, which is F3. And then you're going to choose x squared because this is a parabola, and that's also F3. Then it's going to give you your equation. And so my equation in standard form, because that's what the calculator gives me, is 3x squared plus 30x minus 73. If I double squared that, distributed the negative 3, and added the 2, this is the result I would get. So I know that I have a reflection over the x because it's opening down. I know that I went to the right 5 and up 2 because that's the vertex. And then I have a vertical stretch of 3. And those are my transformations. So that is showing you how to use the calculator and or the pattern from the parent. Okay, over here on the graph again, by knowing pattern, I know that the vertex is at negative 3, negative 5. It's opening up, so far my a value is positive. And then, of course, instead of to the right 1, up 1, I went to the right 2, up 1. And these are lines, so it's rise over run. So that slope is positive 1/2 of rise over run because they're lines. One side's positive, one side's negative, but in absolute value, it's just that's what you're counting, both directions, the slope. So simple enough, f of x equals that vertical compression of 1/2, absolute value, x minus the x coordinate of the vertex, so it became plus 3 minus 5. So I have a vertical compression. I go to the left 3 and down 5. Now the other way to do this is to use the transformed equation to find the A, which means I've got my vertex already in there, but I don't know my A. So we're going to do, and you can use whatever point that you want. You need to use an X and a Y, and I'm going to use this point as my X and Y, and this is my HK. So the transformed equation is f of x equals a x minus h plus k. So now I'm going to plug in what I have. Sorry, I want to put f of x. My y value, which I got from this ordered pair, is -4. I don't know my a. Oops. The x value is -1. The h value is from the vertex at 3, and then -5. Now I'm just going to do the math. Okay, I am going to add my 5 and get 1 is equal to a, and inside here is absolute value of 2, so 1 is equal to 2a, so a is equal to 1/2. And now I have the exact same equation down here. So that's how you can find the 1/2 if you can't get it from the graph. Okay, this is a rational, so from the graph I can see that my asymptote here is at -1, and this asymptote here is at -3. And so that's what I use in my equation, is that -1, -3. I also know that it's from the crossing here of the two asymptotes is normally right 1, up 1. And I'm going right 1, down 2. So that makes my a value -2. So now when I go write this, this is f of x. That -2 is going to be in the numerator. That's where the a value goes. And then x minus the x coordinate of the vertex, so +1, and then -3. Knowing my patterns, I can get that without doing any work. Now, if I need to determine the a value by using the equation, I am going to do f of x equals a, x minus h plus k. So I am going to use the point right there. So -4 is equal to a, 1 minus -1 minus 3. So I'm going to add the 3, which is -1 over a over 2. Multiply both sides by 2, so a equals -2. So I have my transformations are reflect over x, vertical stretch, left 1. I think I got this stopped. Hopefully you got this all, and down 3. So I'm showing you different ways of using it. Rationals and absolute don't have a button in the calculator, so you have to do it the long way.